Guys, welcome back to Data Products with R. In this video, we're going to continue our text mining. We started off by doing all the Jane Austen stuff. Now we're going to jump into the Gutenberg package, where we can use the text from the Gutenberg library to do further analyses. I'm not going to spend too much time blathering. Let's go ahead and get right into it. Okay, so this is where we left off. We had just kind of quantified the Jane Austen words in her 6 novels. So now we're going to do the Gutenberg R Package. Alright, so this package provides access to the public domain works from the Gutenberg project. And I'll just put a link in here, www.gutenberg.org. So these are all old texts that are now in the public domain. So this package includes tools for both downloading books and a complete data set of project Gutenberg metadata that can be used to find works of interest, in this, let's see, we will mostly use the function Gutenberg download, and that's what pulls the data from the R package, that pulls it from the Gutenberg website. So now let's work on word frequencies. So we did this already, but we'll continue to do it. So let's look at some biology texts, starting with Darwin, everyone's favorite. Not really, but as a geneticist, holds a place near and dear. All right, so let's do the voyage of the Beagle, and that's Gutenberg. Each book has its own number, so the voyage of the Beagle is 944, on the origin of species by the means of natural selection, which is 12228. The expression of emotions in man and animals, and that is 1227. And then the last one we'll do is the descent of man, and selection in relation to sex, and that is 2300. So if you go to that website I put above, the Gutenberg.org, and you type in the search 944, it should bring up the Voyage of the Beagle, and if you type in these other ones, etc. But we can access through R these works using the Gutenberg download and the project Gutenberg ID numbers. That's why we put the ID numbers in there. Okay, so first we're going to do library Gutenberg R, and then we're going to say Darwin is a combination of, or is a list of these books. So we're going to Gutenberg R download. So that was the command. And we're going to say a collection of 944, 1227, 1228, and 2300. And then we're going to select a mirror. So what is a mirror? So some of you probably already know this, but a mirror is if you have a database online, a mirror is where they've taken that database and they've put it in different locations. So for example, The Gutenberg library might have their main server of all these books in New York, but then a bunch of different universities also are like, okay, we'll provide more mirrors. And so this gives people more access in case that server goes down. It acts as a backup. So if that server, if there's a fire at that place, all the works aren't lost. It gives you an opportunity to pick a server closest to you so your download speeds are faster, etc. So we're going to select a mirror because for some reason when I wrote this code, the mirror that's default in the Gutenberg R package doesn't work anymore. So I found a mirror that does work, and that mirror is https://mirror2.cndriver.net/pub/Gutenberg. Okay, so this should, of course it doesn't work. Let's see, mirror blah 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 blah, could not find Gutenberg download. Could not find, did I not, oh, wait, Gutenberg R, what did I do here? I spelled it wrong. Gutenberg download. There we go. Okay, that was quick. As you can see now we have up here 79,000 observations of two variables. So, and the Gutenberg ID number is the book, and the text is the line, the sentence or line in the book, right? And so we'll have to break that into tokens like we did before. Okay, so let's break these into tokens, which in our case are words. Oh wait, yeah. So we're gonna call it tidy Darwin is just Darwin, and then we're gonna use the unnest tokens word text. So this is again what breaks them into a new column of only by words. And then anti-join stop words. So we can just put that right into the same command to take out all the ands, thes, ifs, buts, all those words. We can put it right into the same unnest token command because we can just pipe it and just add it in there, right? Okay. There we go. Let's check out what the most common Darwin words are. Okay, so let's do tidy Darwin. Pipe down. And then count word sort equals true. So this will give us the top words that Darwin uses. Interesting. Species. Of all the words, makes sense. The book's called The Origin of Species. Male, males, female, so a lot of stuff about sex and sexual selection. He looked at birds and animals, so this all makes sense. Nothing weird sticks out. Natural, time, vol, so it must be obviously volume. Head, forms, nature, doctor, distinct. These all make sense. Cool. So you can see when compared to Jane Austen, which we did above, we had Miss, time, Fanny, dear, lady, sir, and now we have just biology stuff. Species, male, males, animal, birds, female, sex, etc. So let's keep going. So now let's get some work from Thomas Hunt Morgan, who is credited, I guess, with discovering chromosomes. So another geneticist, evolutionary biologist, etc. So we'll do regeneration which is 57198. The genetic and operative evidence relating to secondary sexual characteristics, which is 57460, and then evolution and adaptation, which is 63540. 540. Okay. Not trivia, but Thomas Hunt Morgan. Where have you heard the word Morgan before? If you've taken genetics or evolution, probably mostly genetics. If you've taken genetics, you know that in linkage mapping and recombination, we measure difference in centimorgans, as in Thomas Hunt Morgan, who did a lot of this work with fruit flies, and you know that centimorgan is just a percentage of recombination frequency. It's not like a real distance, like a Morgan isn't something you can see or anything like that. But anyways, that's where centimorgan comes from. It's Thomas Hunt Morgan. The more you know. So if, when you're on Jeopardy and you win $100 million because you answered the final Jeopardy that Thomas Hunt Morgan had the son of Morgan named after them, send me just a little scratch for that trivia. Okay, let's go. It's late at night here, so I'm getting a little goofy, but that's okay. Moving on. Okay, so Morgan is going to be Gutenberg download, load, C, and then we're going to use those numbers that I had above, 57198, 57460, and 63540, and then the mirror is going to be the same thing. So I'm just going to cut and paste it so we don't have to. I'm just going to cut and paste this whole thing. Because I'm lazy. And oops. Here we go. Why can't I spell this? Gutenberg downloads. What did I spell? Gutenberg. Oh, no S. There we go. Okay, so as you can see here, now we have Morgan. Not quite. We did 3 books versus 4 books for Darwin, but 37,000 lines, so still a very long-winded, who am I to judge somebody for being long-winded? Okay, so let's do, alright, let's tokenize Thomas Hunt Morgan, THM. Okay, Tidy Morgan, instead of Tidy Darwin. Morgan. Unnest tokens. Word. Text. And then anti-join, let's get rid of those stop words. Close that off. And what are THM's most common words? Okay, so Tidy Morgan. Pipe down. Count word sort equals true. Easy breezy, just like we did with Darwin, except for Tidy Morgan. Did I not run this one? There we go. Species. Oh, what are the odds? They both have species. But he's got other words. So we had 4 species and then a bunch of sex stuff. Males, females, sexes, selection, sexual. Morgan, more so. Species, regeneration, piece, cut, males still there. Forms, selection still there. Cells, found, development. As someone that teaches developmental biology, we do a lot with Drosophila, we do a lot with chromosomes, and so that's kind of his focus. Not strict evolution. He does get into evolutionary stuff, but kind of more on the molecular level. Darwin was much more meta, because there wasn't as much knowledge of genetics when although Mendel did discover genetics before Darwin, but there wasn't like a molecular aspect to genetics yet. Anyways, moving on. Okay. Lastly, let's look at Thomas Henry Huxley. So we're going to do evidence as to man's place in nature, which is 2931. On the reception of the origin of species. Excuse me. So it's kind of a review of Darwin. Evolution and ethics and other essays. 2940. Sorry, jeez. Science and culture and other essays. Not essays. He wasn't doing experiments, he was writing essays. There we go. 5, 2, 3, 4, 4. Okay. So we already have Gutenberg R open, so we don't have to do that. So Huxley is going to be Gutenberg downloads C, because we want a collection, 2931 2089 2940 and 52344. And then I hope, yeah, just paste that mirror again, because all the collections are in the same spot, but like I said, the default mirror doesn't work for some reason, so we're going to tell it to use this mirror that conveniently works. If when you're watching this video, for whatever reason, this mirror doesn't work, you can go to Google Gutenberg library mirrors and a list of them will come up, and you just put in the hyperlink for whatever mirror. So if you watch this and I've recorded this 2 years ago in your future, you can always change the mirror. So this isn't for naught. Alright, so tidy Huxley equals Huxley unest tokens word text, and then we're going to pull out the stop words, anti-join, stop words. Okay, so this pulls out the stop words. We did this for the last two, and then let's see what Huxley likes to say. Say tidy Huxley count word sort equals true. So, do you think species is gonna be on there? Number 1, species, nature, time, life, existence, knowledge, animals, nature, animals, science. So, again, we picked 3 evolutionary writers because we wanted some overlap to happen. It's not like if we compare Jane Austen, Albert Einstein, and Charles Darwin, they're just so far out there, or even Darwin and Einstein might be close. So if we picked like Thomas Locke or Karl Marx or some economist, and then Jane Austen, a fiction writer, and then Darwin, it wouldn't be interesting because there would be very little correlation, or the words wouldn't mean anything. But we're going to use, so that's why we're using 3 of the same, 3 evolution writers. Okay, now let's calculate the frequency for each word. Actually, yep, let's do it. Let's finish it out. This might be a little bit of a longer video, but let's just end strong. For each word, for the works of Darwin, Morgan, and Huxley, by binding the data frames, together. So we'll use a function called pivot wider, which takes a data set and can kind of break it apart. Or it takes a narrow data set, so we have all of them lined up together, and it splits them by author. So let's see how this works. Frequency, bind rows, mutate, tidy Morgan, author equals Thomas Hunt Morgan. All right, and then we're going to mutate tidy Darwin, author equals Charles Darwin. There we go. And then mutate, I guess the last one, tidy Huxley, author equals Thomas Henry Huxley. Alright, and now we add a pipe. And we're going to say, why is that doing that there? Oh, I forgot it needs to be one more parentheses. There we go, pipe it down, mutate, word equals str extract, so string extract word. And we're going to say only take A to Z with anything behind it. So this goes back to our regular expression stuff that we did earlier. So we're saying we only want to count words that start with A through Z and have any length. So you don't want because these texts are stored as Unicode 8 files, there are words that will have, or that should be in italics, but they'll put like a slash, an I slash or something like that to say that this word should be translated into italics. Since we have these raw files, those words will show up. And so we're saying get rid of anything that has a weird annotation, like weird not words that exist in here. So that's what that command means. So we want to count author word. So we're saying, all right, now do for each author, count the words and group by the author. So we can see kind of what we saw above, but all as one analysis. And then mutate proportion equals n divided by the sum of n. So you want to see we're essentially sorry, converting this into percentages for each word of the total. And then select and then pivot wider, names from equals author, values from equals proportion, pivot longer, Thomas Hunt Morgan, through Charles Darwin, names to equals author, values to equals proportion. Frequency, so we'll print it out. Okay, so what does this do? Package is not called tidy, it's called tidy R. There we go. Okay, so we said we're going to start with the data frame and we're going to call it frequency. We're going to dump into that our tidy Morgan, tidy Darwin, and tidy Huxley data sets, and we're going to rename them to Thomas Hunt Morgan, which you can see here. We're going to rename it to Charles Darwin, which you can see here. We're going to name it to Thomas Henry Huxley, which you can see here. Then we're going to mutate and we're going to get rid of any weird words that don't start with a letter. So that's what we get there. We're going to count for every author the word, and then we're going to group those words by author. So you can see we have everything in triplicate. So the word A, we have 3 times. So the proportion of all words that Thomas Hunt Morgan wrote that are A is this percent. For Thomas Henry Huxley, it's this percent, etc. So that's what the group by author and the count together do. Mutate, so we're saying take the proportion where whatever word we're on divided by the total of all the words. So that's what gives us this number. So in all of Thomas Hunt Morgan, the word A, or the word abase, it only exists in Darwin. Okay, abandon is a good word. So in all of Thomas Hunt Morgan's words, abandon accounts for this percent, so like less than 1%. So then what we do is we say we're going to pivot wider. So what that does is it puts each author in its own, or it moves, so pivot longer. So the first thing we do is pivot wider, so we compile everything, and then pivot longer, what we do is we say, okay, now what we want to do is have each word appear 3 times, once for each author with each thing. So it makes a wide table longer by compiling, instead of having a row for Thomas, or a column, excuse me, a column for Thomas Hunt Morgan, a column for Thomas Henry Huxley, and a column for Charles Darwin. We've put them together into this table, so they each have their own, or they're all in the same row. Okay, but we're going to move them back eventually. I think that's in this this code. Okay, now we need to change the table so that each author has its own row. So I wanted to show you the pivot longer in that, but we're actually going to break it apart just for our graphing here. Because this is nice because you're able to see the same word for each author, right? And it's in alphabetical order. But now what we're going to do, we're going to do frequency 2, pivot wider, so this is the opposite, so we're going to bring it back. Frequency names from equals author, values from equals proportion. So now you can see what pivot wider does. So we took a wide data set and we made it just 3 columns. Now we're taking a 3-column data set, and let's print frequency 2. And now we've done it where we've taken that center column and made it into each their own column, and we put proportion as the values in there. So this is going to help us for graphing. That's why we're doing this. Now let's plot. So, almost at 30 minutes. We're almost done. Library scales is what we're going to use. So, ggplot. Frequency 2. Aesthetic. X equals proportion. Y equals author. Color equals the absolute of author minus proportion. Row proportion. All right, and let's do geom AB line. So we're going to add a line. Color equals gray 30. LTY equals 2. So line type equals 2. Geom jitter, jitter, alpha equals 0.1, size equals 2.5, width equals 0.3, height equals 0.3, and geom text or aesthetic labels equals word, check overlap equals true, which should make sure our words don't overlap. If they do, they get rid of those words, because otherwise you just can't see anything. VJust justification equals 1.5. Scale x log 10. Labels equals percent format. So we're going to put it on a log scale so you can see what's going on. Scale y log 10. Labels equals percent format. Okay, scale. This one you'll know. Color gradient limits equals C 0, 0.001. Low equals, you can pick whatever colors you want here. Dark slate gray 4. High equals gray 75. If you pick funky colors, it might not work very well. Facet wrap by author, end column equals 2, and theme legend position equals, we'll say none, you don't need a legend for this. And then labs, y equals Darwin, x equals null. Oh, after all that typing, I hope this works. Gradients. Where do I have gradient in here? Plus scale color gradient. Limites. Always a typo. Darse. Dark. Slate gray. Look. Null. All capitals for null. Now what? Alright, let's see. Y color. Y equals author. Color equals M's. Author minus proportion. Let's be kind of lazy here. Author minus proportion. Oh. I wonder. Oh, this has to be changed here. Okay. So because our columns aren't, we need to change this abs here. So we want to measure Charles Darwin minus Thomas Hunt Morgan. And our x is going to be proportion. It's because I changed this code. So our x is going to be Charles Darwin. And our y is going to be Thomas Hunt Morgan. Okay, let's see if this works. And then I don't know why I put Jane Austen on here. So our x equals Charles Darwin. Y equals Thomas Hunt Morgan. All right. X equals Charles. Make sure I spelled everything right. Y equals Thomas Hunt Morgan. Let's put that in there. Color equals abs. Let's get rid of that. Ugh. Okay, so I cheated. I couldn't find my typo. We're at 36 minutes, and I don't want you to sit here forever. So, I just cut and pasted for my code I wrote earlier that I am using as an outline. If you're not getting it to work, pause it right here, freeze, and copy this code, because this works. Because like I said, I don't want this video to go super long. So, as you can see here, what we've made is a comparison of the frequency of words for Charles Darwin and Thomas Hunt Morgan, where it also, depending on the correlation between the two, we have the straight lines, so things that are more in the center here, or along this line, is a one-to-one correlation. Things like regeneration skew more towards Thomas Hunt Morgan than they do Darwin. Things like islands, which he was at the Galapagos Islands, skew more towards Darwin than they do Thomas Hunt Morgan. And the alpha, the darker it gets, means there's more overlaid points. So, this is kind of cool. So you can kind of compare, these terms between different authors. And we'll get more into this, it'll make more biological sense as we go. This is just kind of laying the baseline. But so, like I said, since we're at 36 minutes, I am going to just paste the same comparison. So we did Darwin and Thomas Hunt Morgan. All you have to do is change the names. So instead of Thomas Hunt Morgan, just replace it with Thomas Henry Huxley. Anytime in this block, if we run it, we have now a comparison between Thomas Henry Huxley and Charles Darwin. So you can see it's a little bit different. Species makes up a big proportion for both of them. Sexual is more Darwin. Ethical, because remember he wrote those ethics books, much more Thomas Henry Huxley. And lastly, in the interest of time, I will paste the comparison of the Thomases. Thomas Henry Huxley versus Thomas Hunt Morgan. It's even hard because they both have same middle initial too, right? Okay, so you can see here, now we have the comparison of the last two. So we have Thomas Hunt Morgan, Thomas Henry Huxley. Species, again, is common between both. Thomas Henry Huxley, the ethics guy, moral, knowledge, doctrines, kind of existence, so kind of some theology or some philosophy involved, regeneration for Thompson Morgan. Not sure why cock is on there. Ancestral cells, acquired, change, account, because he worked with Drosophila a lot, tail, breed, cells, eggs, etc. Animal. Maybe he did work with poultry. I'm not sure. Okay, so I'm sorry this was long. I could have maybe divided it into 2 lectures, but it just wasn't a very good point to divide it. So I'm not going to make this any longer than it has to be 40 minutes as long. Thank you for sticking with me. I really appreciate it. I hope you learned something. I hope you had a little bit of fun of comparing evolutionary text for word frequencies. We'll get more into it. We'll be able to assign values pretty soon. Because for sentiment, like, we want to say this word is really negative or this word is really positive. So if we were to measure someone's reaction to something like COVID or whatever, we can quantify it. Because right now we can say, okay, there's a one-to-one relationship or there's no relationship between these words and these different authors, but we're going to expand upon that. No more talking. With that, thank you for watching. I hope you enjoyed the lecture. If you're watching on YouTube, hit like, hit subscribe, ring the bell, so to speak. And we'll continue on our journey into sentiment analysis, and I will catch you